All right, so objective two here is going to look at these errors that you can make when making your decisions. So again, sometimes, based off our data, we think something is correct, or we think something's right, and ends up not being correct. All right, so again, type one error. It occurs if a test rejects the null when the null is true. That is, the test finds convincing evidence that the alternative hypothesis is true when it actually isn't. All right, that's a type one error. So we reject the null, but the null is true. And a type 2 error, it occurs if a test fails to reject the null when the alternative is true. That is, the test does not find convincing evidence that the alternative is true when it actually is. All right, so in type 1, we went with the alternative, we shouldn't have. In type 2, we did not go with the alternative, but we should have. Okay, so that's the idea here. Here is sort of a table to try to help you. So again, your conclusion based on your sample. So when you reject the null, but the null is true, that's your type 1 error. So again, that's our first issue. So when you reject the null, but the null is true, that's your type 2. And then your type 1 error. And your type 2 error is when you fail to reject the null, when you don't go with the alternative, but the alternative is true. Now, I've changed these lowercase a's to capital A's. So that should be a capital A, sorry. Okay. So again, errors happen, right? We are not error proof. Human error all over the place. All right, so let's take a look at this example. It says, can we make fast food faster? The manager of a fast food restaurant wants to reduce the proportion of drive-through customers who have to wait longer than 2 minutes to receive their food after placing an order. Based on store records, the proportion of customers who had to wait longer than 2 minutes was P equals 0.63. To reduce this proportion, the manager assigns an additional employee to assist with drive-through orders. During the next month, the manager will collect a random sample of 250 drive-through times and test the following hypotheses at the alpha equals 0.10 significance level. Null hypothesis, the proportion is equal to 0.63. The alternative, the proportion is less than 0.63, where P equals the true proportion of drive-through customers who have to wait longer than 2 minutes to receive their food. Describe a type 1 error in this setting. Okay, so in a type 1 error, we reject the null when the null is true. So we're saying that the time is actually going to be less than 0.63, when in actuality it is equal to 0.63. Type 1 error, here it comes. So we're going to say something like this. The manager found convincing evidence that, and now again, we're going to look right here. And again, it's a little wordy, sorry, that the true proportion of drive-through customers who had to wait longer than 2 minutes I was going to put 4, but to receive their food. To receive, I before E except after C. To receive their food. And now, when you do this, it's about the alternative. Is less than 0.63. When it is actually still equal to 0.63. Okay, so again, we rejected the null. We thought that we found convincing evidence for the alternative. We were wrong. It's still just 0.63. Error. Okay, again, copy and paste feature. B. Now we're going to describe a type 2 error. So now in the type 2 error, we fail to reject the null when we really should have. All right. So in this case, if you fail to reject an all, that means the manager did not find convincing evidence that, and again, we're going to copy that down. That's why your copy and paste feature did not find convincing evidence that the true proportion of drive-through customers who had to wait longer than 2 minutes to receive their food did not find convincing evidence that the is less than 0.63 when it is actually less than 0.63. Okay. So again, we did not find convincing evidence to throw away the null and say that the proportion is actually the portion is less than 0.63. But in reality, in all actuality, it is really less than 0.63. Okay. So again, sometimes our sample values, right, depending on what our sample value comes out to be, sometimes it misleads our decision making, right? It's hard to always just base off of one sample. You hope you do the right thing, but that takes time and money. All right, and effort. All right, this is objective 2. Objective 3 is coming.